In the last session, we have discussed about rectangular window, designing of FIR filters using windowing techniques. And why we are going for windowing techniques means to decrease the infinite series length into finite series length. So if we do the Fourier transform or inverse Fourier transform, we'll get the functions which are having the limits from minus infinity to plus infinity. So we have to truncate the series length because it is a finite impulse response we are dealing with FIR filters. So we have to get the limits with finite limits. So how to truncate the infinite series length into finite series length means by multiplying the HD of n with the window function, we'll get finite series length. So first window technique is a rectangular window technique. The rectangular window shape is like this. In the middle I am having magnitude 1, but at the ends suddenly the amplitude is going to decrease from 1 to 0. So there is sudden truncation, high magnitude to low magnitude. This sudden truncation will causes the oscillations in the stop band and the pass band, which are not highly desirable. So this is a one disadvantage in rectangular window. And what are the advantages in a rectangular window? Main lobe width is 4 pi by n, that is very less, and higher side lobe level. These are the side lobes. Higher side lobe level is nothing but first side lobe. This first side lobes should be as much as low compared to the main lobe amplitude. So these are two desirable things we can get in the rectangular window. And as the order is increasing, the main lobe width will decrease and the transition band width is also decreases, which are mostly desirable. Okay. So next, triangular window. So in the triangular window, if we see the diagram, higher magnitude is like this, and if we are going left side or right side, the magnitude is slowly decreasing to 0. That is, the sudden truncation is not doing by using triangular window. There is a smooth truncation. So by doing this, we won't get the oscillations in the stop band and pass band. We'll get smooth curves in the stop band and pass band. If we consider the low pass filter, we'll get like this, smooth curves. There is no oscillations in the stop band and the pass band. This is the one advantage of the triangular window. But what are the disadvantages we are having is transition bandwidth is very high and that attenuation in the side band is very less. If the transition band is very high, we can't differentiate between the pass band and stop band easily. The attenuation for the side band is also very less, the same problem. Stop band and pass band will be looking same. So these are the disadvantages in the triangular window. So that's why we are going for raised cosine window. Okay. So next topic and very important topic is raised cosine window. It is having the window function like this: W alpha of n is equal to alpha plus 1 minus alpha into cos of 2 pi n by n minus 1, and where the n is in between magnitude of n, it is nothing but plus or minus n minus 1 by 2, and greater than plus or minus n minus 1 by 2, it won't have any function. This is raised cosine window function. Next, what we will do, the same process we did for the rectangular window, same process we have to follow for raised cosine window. That is frequency response. I want to find out. So by seeing the frequency response, we can observe what is the transition bandwidth region, what about the main lobe widths, and how about the side lobe amplitudes. These can be analyzed by using this frequency response. So how to get this frequency response? W alpha of e power j omega is summation n is equal to minus n minus 1 by 2 to plus n minus 1 by 2 into h of n is nothing but above function alpha plus 1 minus alpha into cos of 2 pi n by n minus 1 into e power minus j omega n. So actually h of n is nothing but hd of n wd of n. Here wd of n is nothing but w alpha of n, and here hd of n I am considering it as 1. For every window function we can consider this desired function as a 1. So to analyze each and every window, we can consider it as a 1 or we can neglect this one. So directly h of n is nothing but this window function we can write. That's why I have written like this. So now simplification, n minus 1 by 2, 2 plus n minus 1 by 2 alpha into e power minus j omega n plus summation n is equal to minus of n minus 1 by 2 to plus n minus 1 by 2 into 1 minus alpha into e power minus j omega n into, here cos theta is nothing but e power j theta plus e power minus j theta by 2. So e power j 2 pi n by n minus 1 plus e power minus j 2 pi n by n minus 1 by 2. Here I am writing. Okay. So now I am having three functions. This is a function, e power j summation as b, and e power minus j summation as c. Now simplify only a first. The same process we can do for b and c. So alpha into e power minus j omega n. First I am expanding the series. Minus j omega into n. N is nothing but here minus of n minus 1 by 2. So plus j omega n minus 1 by 2. After expanding like this, I will get e power j omega, next 1, next e power minus j omega up to e power minus j omega n minus 1 by 2. So in the expansion, I am taking the first term as a common term. So I will get e power minus j omega, e power minus 2j omega up to e power minus j omega into n minus 1. So this term is nothing but 1 plus a square up to a power n minus 1. It is nothing but 1 minus a power n by 1 minus a. Here a is nothing but e power minus j omega. So this can be written as e power j omega n minus 1 by 2 into 1 minus e power minus j omega n by 1 minus e power minus j omega. Multiply this inside by e power j omega n by 2. This function can be written as e power j omega n by 2 into e power minus j omega by 2. E power minus j omega by 2 can be written as 1 by e power j omega by 2. Next, multiply these terms inside. We will get e power j omega n by 2 minus e power minus j omega n by 2 by e power j omega by 2 minus e power minus j omega by 2. E power j theta minus e power minus j theta, that is nothing but 2j sin theta. So here 2j sin omega n by 2 by 2j sin omega by 2. Sin by sin is nothing but sinc function. Next, consider b term. 1 minus alpha by 2 summation n is equal to minus of n minus 1 by 2 to plus n minus 1 by 2 into e power minus j omega n into e power j 2 pi n by n minus 1. Similarly, see same function, instead of minus j plus j, here I will have minus j. Now do the simplification. So this can be written as, only these two terms can be written as, if I take minus j as common, minus jn as common, I will get minus jn as a common term. Omega minus 2 pi n by n minus 1 as a exponential term in the equation. So now just expand the summation by substituting n is equal to this one and this one as we did for a term. E power minus term, so minus minus will become plus j omega minus 2 pi, here I won't get n term because already we took n as a common term, omega minus 2 pi by n minus 1 into n minus 1 by 2. Next e power j omega minus 2 pi by n minus 1 plus 1 plus e power minus j omega minus 2 pi by n minus 1 e power minus j omega minus 2 pi by n minus 1 into n minus 1 by 2. So if I take first term as a common term, e power j omega minus 2 pi by n minus 1 into n minus 1 by 2 as a common term, I will get 1 minus e power minus j omega minus 2 pi by n minus 1 into capital N by 1 minus e power minus j omega minus 2 pi by n minus 1. So this is nothing but 1 minus a power n by 1 minus a. So the function which can be written as e power j omega minus 2 pi by n minus 1 into capital N by 2, and this can be written as e power j omega minus 2 pi by n minus 1 into minus 1 by 2. Minus 1 by 2 can be written as here 1 by 2 into the function 1 minus e power minus j omega minus 2 pi by n minus 1 by 1 minus e power minus j omega minus 2 pi by n minus 1. Okay, next multiply this function inside, we'll get sine function by sine function, just like a sinc function. Okay, similarly for c, what is the difference for c? We will get, instead of here plus minus symbol, we'll get a plus symbol inside. We have here 1 minus e power minus j omega minus 2 pi by n minus 1 by 1 minus e power minus j omega minus 2 pi by n minus 1. So 1 minus alpha by 2 into multiply inside e power j omega minus 2 pi by n minus 1 into n by 2 minus e power minus j omega minus 2 pi by n minus 1 into n by 2 by e power j omega minus 2 pi by n minus 1 into 1 by 2 minus e power minus j omega minus 2 pi by n minus 1 here.